Okay, and I've got to get rid of the window on the other screen. Okay, and back here to recover my mouse. Okay. Make it a little bit bigger. And okay, so let's start. I did paste a link to the Google Drive. You had it before, but I pasted it once more so that you can get there. I did drop there the current version of the day 2 file we're gonna be working today. It's been updated like within the last half an hour or so. So if you've got something from earlier on, I would suggest you get the link is in the chat. If you check in the chat, there is a link to drive.google.com, whatever. So that's sorry, it's not there. I made it private to Eloy. Just a moment. Let's everyone. Sorry about that. Oh, I think that's the one. Okay. Yes, Stacy was correct. It went to Eloy. So now it should be fine. Okay, so there's a day2 student .py file which is the current version of the file we're gonna go through. If you got some earlier version, you'd probably be better off getting newer one because it's gonna be in sync with whatever I've got here. This one was modified just half an hour ago or so. Okay, so let's try to recapitulate what we were doing yesterday, which parts of Python we went through yesterday. Okay, so let's see, what do we have. So we went first through a number of different data types that we can deal with in Python. The simplest one was probably a Boolean data type, which allows you to store in a variable or manipulate true and false values. So this is like, we can say my bool equals true. This is gonna assign a true value to a variable called my boolean. As you probably remember, an assignment operation means that we're taking what's on the right side of a equal sign and put it into a variable on the left side. Okay, we can also set my or let's call it my true, my false. We can set it to stop codon. We'll get there with the function. Okay, let's go false. This is the false value. We can print either. We can print my true, true, and my false, and then we get the output generated by calling the print function. We can check what's the type of a variable by calling a type function and passing a name of the variable. Let's say my true. Okay, and here the printout tells us that the last argument passed to print was of a type or of a class bool or boolean. Okay, and with Boolean values, we can perform logical operations and or negation. So we can write expressions like my true and and my false, and my false. This is gonna be most likely false. If we now do my true or my false, false, we're gonna get true. That's how logical and or operations work. We can negate either one of the arguments in the expression here, or we can negate everything by saying not and put whatever we want to negate in parentheses, and now we're gonna get negated version of my true or my false. So this is conventional Boolean logic and Boolean math and logical operations. Okay, so that's the simplest possible type. It allows you, data type allows you to store two values, one true, one false. Another data type we went through or two data types were numbers. We had integers. We can say my int is, let's say, 1, 2, 3, 4. This is gonna be an integer number. It can be either positive or negative. We can, as with the Booleans, we can print it. Print my int to get the number. We can also deal with floating point numbers, with the decimal points, with fractional part, my float, and we can either say 1, 2, 3, 4 and the decimal part like this, or we can use scientific notation and we can say something like 1, 2, 3, 4, 5 e to third. So we can use those two ways of specifying floating point constants and assign them to a number. And then once more, if we print my float, then we're getting the output. If you may notice that with default way the print function works, integers don't show up, decimal part, floating points do. It holds even if decimal part is 0. So it's a way to tell that the number is of a floating point type by just printing it. This is a integer number because there's nothing, no fractional part with the floating point. With the 0 as a fractional part, there's still the 0 printed out, so you can tell by printing those things. And the other way to check what's the type is once more doing type, and then looking for my float, and now the type function is gonna return something which prints out as information that our variable was of a type or of a class float. So those are the numbers, and with numbers we can perform standard math operations. We can write expressions using different math operations. We can mix integers and floats, and they will be converted into the proper version to get the expression going. So we can say standard things. Let's say I'm gonna make something shorter to type. So A is 1, B is 2, C is, let's say, is -3, and we can say something like A times B plus C, and the expression is going to be evaluated according to the order in a correct math order. If we want to change the ordered operations are performed, we've got to enforce it by putting brackets in wherever places we want. So this is standard math notations. Besides additions and subtractions, we can the multiplication and division. We can raise a number to a power using star notation. So this is gonna raise a to the power of 2, which is useless because it's gonna be still 1. So we can raise b to the second power to get 4. We can use fractional exponent to get the square root. So this is basic math. It is relatively common that we want to calculate things like, let's say, a equals a plus 1. So we want to increment a certain variable by 1. And expressions like this, assignments like this, looking like this, are quite common. So there's a shortcut for that. Just before that, just as a reminder, what this is gonna do is it's gonna look what's the current version of a. It's gonna add to this current version of a1, and then after addition, the resulting value is gonna be stored back into the a variable. So this is not the equation in a sense of a math equation. This is always assignment. We calculate whatever is on the right side of the equal sign first, and then you put it, we put it into whatever is on the left side. So that's how expressions like this look like. So if we set, let's say, a here to, let's say, 5, and we print a, and then increment it and print a, we're gonna get 5 from the first print statement and then 6 from the second one. The shortcut is typing plus equal 1. Expression like this means take a, add 1 to it, store it back in a. So this is exactly the same as a equal a plus 1. That's how those operation plus assignment work. So here's addition, and as you can see, the output is exactly the same. We're getting 5 from the first print statement and then 6 from the second one. It works also for subtraction, multiplication, and division. All those three variants are also there. The most commonly used is though the plus equal, just the increment part. So this is the basic math. Thing to pay attention is that if you're dealing with numbers, with calculations that require high accuracy, then you might run into you might run into problems because the accuracy of the floating point numbers is limited. In general, if we, let's say, try to add two numbers that are very, very different in terms of magnitude, let's say 1 plus 1 to plus 1 to times 10 to minus 15th, this one still registers. We actually do see the effect of addition, but if the added number is much smaller, then then it's not added. This is a reflection of limited number of decimal points that are available. For floating point numbers, in general, there's about 16, about 15 significant digits in those numbers. So as long as the difference, the dynamic range of your numbers is less than 10 to 15, you're fine. If the range is bigger than special precautions got to be taken. It's outside of the scope of just standard Python coding. It's if there's a problem, then you've got to start looking to numerical analysis and how problems like that are handled to avoid accumulation of errors. But thing to be aware of is that there are cases where computations are not exact. With integers, there's not a problem. Integers do store arbitrary large numbers, and accuracy is kept there, but it's only within integer domain. If some part of the calculation there involves divisions, for example, then you might run into problems with accuracy. So that's how the numbers are dealt with. And now, so though this is a very rapid intro to Boolean values and numbers, and then fourth in two flavors. One thing that I also mentioned is that in case of division, we've got two flavors. We can divide two numbers as integers or as floating points. With floating points, is the standard division side. So we can divide, let's say, C divided by B. This is gonna give us -1/2 because we're dividing -3 by 2. If we want to perform integer division, we double the divide sign slash, and then the result is gonna be in integer. The complementary operation is getting the remainder from the integer division, which we can get by using the percent character as a sign, as marking the operation, and then the remainder is gonna be 1 here. So this is integer division and remainder, or a modulo. Okay, so these are the basics of dealing with numbers. Now the last data type we went through were strings, which are just a collection of characters. Let's say my string, let's make it ATGC, ATTA, ATGAC, something like that. Here we've got a string. We can, as before, print it. My string and run it. So here's the printed string. We can check what's the type of my string, and here's the and so the class is gonna be that the type is gonna be str, and we can convert between the data types. So we can coerce or cast one variable of one type into another, provided conversion makes sense. So we can, for example, have a string, let's say my s string integer, and we can have a string that looks like 1, 2, 3, 5, for example, and we can, if we check type of my s integer, now this type is gonna be string, but we can force or coerce or cast the string into a number by saying, let's say, int my s my s int. So here I'm taking the my s int variable that's storing a string composed of four characters, and now I'm converting it into integer, and then after conversion I'm testing what's the result, what's the type of the result. If I run it now, the type of the converted string is integer, because that's what I did here. And then I can also convert it into a Boolean, into a float, and here I'm getting a float. Now if I print it, when I print it, it's gonna be printed according to the default way the floating point numbers are. So you're gonna see a decimal point. So here you see that I've started from a string corresponding to a number. After conversion to a floating point, the default way, the default format of printing floating points is resulting in additional digit after decimal point. So the conversion worked here. If we print just the initial string my s int, we're gonna stay with the original string printed out. So other conversions are also possible. So we can convert, for example, between let's make it back to a number. We can convert integer to a float. And so here I'm starting with a variable that's storing an integer, and now I'm converting it into a floating point. And once more, conversion works. If I can go in the opposite direction, I can have float 1, 2, 3, let's say like this, and then I can convert it into integer, my float, and my float. Now when I run it, my float, why is it not printing? This should print out decimal point, I would think. Let's see. Okay, what about this one? This one. Oh, that's interesting. I didn't know about it. So I would guess that here I should have this my float printed out with the decimal part, but I didn't. So this is sort of a surprising, but well, that's how it works. So if in doubt, one can always check what's going on. I just wonder why. What if I do? Oh no, that's fine, because I know what was happening. So here is my wishful thinking that I'm storing a floating point. I've got to actually store a floating point number using a constant which generates floating points. So I've got to add the small point here. So now it's gonna work as it should. So here I'm printing out a floating point number here as a second argument. So here it's printed out with the decimal part. When I'm converting into an integer, the decimal part is not printed because integers don't have a decimal part. The danger with a conversion like that is if you've got a floating point number with decimal part, then the conversion to integer is gonna lose it. So here's our initial floating point. After conversion to integer, this thing disappeared. So some conversions might give you in string plus. Yeah. So some conversions might result in losing accuracy or some extra effects that is worth to be aware of. So that's the conversion between types. And going back, one useful conversion is conversion between conversion into Booleans. Let's say we want to make a Boolean out of a number. Let's get 1, 2, 3, 4, 5. Let's try to convert to coarse number into Boolean and see what happens. Well, we're getting true. If we're getting a negative number, we're still getting true. So it means any number, and the only way to get false is to have a number equal to 0, and then we're getting false. So it means that any non-zero number can be interpreted as a true value. Any number set to 0 is corresponding to false. I think it's gonna hold both for integers as I tried here, and for floating point. Here is a floating point set to 0. It's false. If the number is non-zero, it's true. So this conversion is applied very often. It's applied when expression in a conditional statements in if statements are returning numbers. So if you've got if statement with let's say looking at, we've got somewhere there a, let's say if a print a. So this is simplest possible conditional statement. We're just checking what's the value returned by expression following a. In our following if, in our case, there's expression composed of just a single variable. Then if this expression is evaluated to true, the block after if is gonna be run. Let's see what happens. Well, I'm gonna kill other things because they are getting in the way. So let's comment this thing out. Okay, and let's see what happens. Well, nothing happens. I'm gonna print myself something to mark where I am. Okay, so I'm expecting to see at the very end a bunch of dashes and then result from our if statement. If I run it here, I do see 6 printed out. This is because a is non-zero, so it's interpreted as true, and then the block executes. If a happens to be 0, so let's make ourselves a equal 0. Then we don't see the output, so this print statement was skipped, and that's because values interpreted as values, the expressions resulting in 0 are interpreted as false. You can think about it as though every expression that you put here is actually wrapped in a Boole conversion. This is another way of thinking about if a condition, or another version is if a equal is not equal to 0, then we can print a. So those if a print a if bool a and if a not equal 0, those three forms are equivalent. This is exactly the same effect. It's just that the way it's written is different, but internally this thing is gonna be executed the same way. We can have something more complicated here. Obviously, we can have a plus b, and then print a plus b. So whatever goes after if can be any expression, as long as expression is valid. It's gonna return something that then is gonna be cast into logical true or false, and then depending on the result, we're gonna see the block executed or not. So that's one more convenient conversion. Going back to strings. Let's get my string here, and let's put it into separate cell. So here's our string. Apart from printing and checking what's the type, we can do other things with strings. We can check what's the length of the string by typing len, and then my str. This is gonna tell us how many characters is there in the string. Here's the number. If we've got two strings, my str, let's say 1, and if we've got two strings, we want to merge or concatenate. We can just use addition operator. We can do something like my str1 plus my str2. This plus, when applied to two strings, means concatenate those strings together. So if we print it, we're gonna have 3 C's tagged after the last character in the first string. This will not work when we've got numbers here. So if we try to concatenate a string with, let's say, an integer, then we're gonna get type error, because and the interpreter is gonna tell us that we can concatenate only string to another string, not integer. The solution is cast our number into string. We know how to do it. We can do str and convert the number to a string, and now we've got proper behavior. The two strings were concatenated. The first part is coming from my str1. The second part is a number 1, 2, 3 converted into a string. This is one of the ways of making printouts nice we can make a sticker, we can make a label. This is, let's say, my number. So we can make a nice sticker and then concatenate it with the number, and then the printout will make us something that looks nicer than the raw things I was using before. So this is, and then another way of building strings is multiplying them by number. If we want to get something composed of repeated units with a certain number of repetitions, we can say, let's make a space here times 5. So now if we just look at my str tool, we're gonna have 5 repetitions of the unit string we started with. So this is how to build strings. We can get the length of the string. What else we can do with strings? We can convert between the cases. We can make a string that's all in all capitals into a string, corresponding string with the using lower case numbers by typing lower my str1, and this is low. No, it's not. No. Ah, sorry, it's not the function. It's a method. So we've got to be lower than this. Let's see. Yeah. So this is so-called method. This is a function or something that behaves like a function, but it's applied to a variable or a piece of data of a given type. For strings, we do have a method called lower, which converts our initial string in uppercase into all lowercase character. The inverse is upper, so we can store our lowercase is my low, for example. So now we're storing the lowercase string in a my low, and now we can go back. We can do my low. My low into upper thing, and this returns us back to the uppercase. So here's the conversion between uppercase and lowercase character, but it's applied to, the conversion is applied to every character in a string. So far we didn't get into how to get to one particular character in a string. For us at this moment, the string is just one variable, not without smaller parts. So what are the other things we can do? We can check if there is a certain character or a sequence in a or a substring in a given string by using a find method. We can do, let's say, my str1 find, let's say, t, and let's see what this thing is gonna do. Well, it's gonna give us the position of the first character. It's provided as an argument or a first sequence if we use more than one character in our argument. So if we use, let's say, t, g, and do find, we're still getting tg starting from here. This is boring, so let's make it the gc. Let's say gc rank. So here finding gc returns 2, it is because the characters are numbered starting from 0. So A is 0, T is 1, G is 2, and our find found the first occurrence of GC and returned the position of the first character in a substring, which happens to be 2. It does not return. The position returned is position of the very first occurrence of a character or a string. So if we look for, let's say, T, find is gonna tell us that the first T is at position 1 here, but it's oblivious of whatever follows. So that's the binding. This is basic version of a find method. If we want, if we want to know how many T's is there, we can use a count method. My str1 count T, and if we now run it, we're getting 5 return because there's 1, 2, 3, 4, 5 T's in a string. So we can find if a given string or if a given character or a substring is present in our string, and we can count how many times it does occur. So that's how to find things in a string. We can check if string starts with a given substring. So we can do we can check if my str1 starts with, and let's say we can say something like this. Let's say ATG. Well, starts with, yes, the answer is true because our MyStr1 starts with ATG. If we check, if we try to look for TG at the beginning of a string, we're getting false because our string doesn't start with TG. Another way of finding things in a string, another option finding strings in a finding substrings or characters in a string is to use in operator. So we can check if, well, let's say we can type T. If we can check if T is in my str1, and I don't want those two. So here, yes, T is in my str1. Find is, it might work. I'm not sure, but it might work with find. Will work with other. It will work with lists. It will work with dictionaries. So find is more universal, but the same thing holds for in. So those two things work in more than for more than one data type. So the difference between find and in that's sort of useful is that find allows you to restrict the region of a string that you're looking for, that you're searching through. So find in principle takes additional arguments. You can say find, let's say 5 to 7, and this and this is going to check if there is a T between the 5th character up to 7th. So that's advantage of find. You can limit the range where things where you're looking for. Only, yeah. So well, with two more, well, you can always do find, let's say t. So you can look for a sequence of TT inside my str1. This is also fine. So you can look for, let's say ATG, and now it didn't find anything, and it's returning. If find didn't found the substring you're looking for, the result is going to be -1. That's how find reports that there's nothing found in a sequence. So that's how to find things in strings. And now going back to our problem from yesterday. So let's see, what was the problem. Let me get this thing here. Okay, let's go here and let's see what we want. Okay, so what we want to do is we want to write a function that is gonna take a piece of string as an argument, okay, and then it's supposed to find stop codons there. I need the cheat sheet because I don't remember what are the stop codons, so I'm gonna do a rapid search for a codon table. Okay, and then there's gonna be something here. So now we can check stops are TA, G, and where is it? Not this one. Here, and let's get it here. Okay, so we're looking for TAA, TAG, and TGA. Okay, stop codons. So, well, there's more than one way to do it, but we've got to start by defining a function. Functions are defined by saying def, and let's say has stop. So we've got the def word signifying that we're going to write the definition of a function. Then there's a function name. Then there's going to be a list of arguments. We're going to have mysec. We're going to have, let's say, sequence as an argument. And now inside the body of a function, we've got to start writing the code that's going to actually do whatever we want. So just to make sure that, just to safeguard us from dealing with sequences provided as a lowercase or uppercase characters, I'm gonna first convert the incoming argument into lowercase characters. This way, the function will be able to deal with both uppercase, lowercase sequences in case someone used the wrong case. So I'm gonna first do sec equals sec lower, and this guarantees that from now on I'm dealing only with lowercase characters. So for now I'm just gonna do print our sequence to see what happens and run it by calling the function. So once the function is defined, now I can call it. I can call has sec with my sequence, and here's the call to a function which is going to result in running the code of a provided in the body of a function using the argument wherever it's used inside the definition. So once we run it, now we've got the stop. So my set here, as you see, making typos is common. So then you've got to find out where's the problem. So far our function is just printing out lowercase of the string. So now we've got to find if there's a stop codon there. There's more than one way to do it. Let's do something ugly. Where at the end of today we're gonna do it in a much simpler way. But this is just to play with writing a function for a moment. So we can so we've got to find a stop codon somewhere in the string, and we've got 3 different versions of the stop codons to check. So we've got to sequentially check one after the other to see if any one of those is present. So let's try with TAA. So we do need a position to be reported, so we're gonna use the find function. So let's start with finding TAA in a sec. So let's get our position set by calling a find method on a sequence, and we want to find TAA, and we want to use lowercase because we're converting everything for consistency to lowercase. So we want to look for TAA. Okay, and now we know that if the number is negative, there's no TAA present in the sequence. So then we've got to continue on and look for the other 2. So we can use if statement and check if pos is less than 0, then we're gonna look for one more version of a stop codon for, let's say, TAG. Okay, so now the story repeats itself. If after the second find the pos is negative, we're still looking for a stop codon. So we've got the third option, copy. So we're gonna look for TGA, and now we've got two possibilities. The pos might be still -1. It means there's no stop codon there. So now if pos is less than 0, it means we run out of stop codons to check for, and we don't have a stop codon, so we're supposed to print out stop codon not present. So we're just gonna print stop codon here, and otherwise, so else we're gonna print, okay, and we're gonna print stop codon present at position as it's here, and then we can print our pos. Okay, so here's one version of the function that I asked for. We can check if it works, if there are any typos or what's going on by just running it. and we're getting that information that stop codon is present at position 5. Is it true? Well, let's see. 1, 0, 1, 2, 3, 4, 5. There's a TAG here, and this is one of the stop codons that we're looking for. So apparently the answer is conforming to whatever the request for the function was. So this is by no means perfect or that useful. The reason is, you can come up with many reasons. It's gonna find you only one of the 3 possible stop codons. Gonna find you only the first occurrence of those, and it's checking stop codons in a some arbitrary order. So if there's a TG in front of TAA, preceding TAA, still TAG is gonna be reported, but not TAA. So this is a very poor version of the function, but it's doing whatever the request is asking for. So we'll go at the end of today. We'll go through a little bit better version of getting post referenced before assignment. You shouldn't, because, well, let's see. Let me clear everything. If there are problems like Zachary is asking, we can see what's going on by clearing the console, removing all variables. Okay, so now we don't have any variables defined, and now let's see if it's running now. No, it's fine. So it's running as it should. So it means you've got. Well, it should be. The answer should be the same, no matter TGC T. No, it should be the same. So there's got to be a typo. Something, or maybe your sequence is slightly different. So this, but there should be no problem with post not defined. You would get the error message about the variable not being defined if I skipped the first assignment. Let's try what's going on if the first find is skipped. So now what's gonna happen is you're gonna have local variable reference before assignment. This is because we're trying to check what's in a post variable before actually assigning any value to it. So this is not allowed. This is potentially dangerous to write code which relies on undefined value in a variable. So Python doesn't let you do it, and flags it as an error. So post got to be first assigned to, and only then you can use it in conditionals. You can use it in expressions if the value is not there, then you're gonna get information about post reference before assignment. It means that you're trying to get the value in a post variable before setting it for the first time. So this is one possible. This is the typical case where you see the error message like here. Okay, so and then indentation is another. If indentation is wrong, then you might have problems, and you're gonna get errors. But then you're gonna get indentation error. It's gonna tell you what's the problem. So, and you're gonna see somewhere in a printout where's the fragment of code that generated the error. So the spider's trying to be helpful and show you where the potential errors might be showing up. So then this is easy to fix by by just making sure things are aligned in a proper proper way. Okay. Yes, there's more than one way. But going over more than one position involves repeating things over and over again. So we've got to get into loops before looking for multiple occurrences of things in a string. So yes, there's more than one way to finding all the stop codons, but it will have to wait till tomorrow, let's say. So there's more things more constructs to learn to get to that stage. So one thing that's useful with functions is they can have arguments that are set to a default value. Here our let me make a copy of this thing, and let's start. Let me make a copy of this thing. Why no? Okay, here, and let's make another cell. Okay, so the function here takes only one argument, and when you run it, when you call this function, you do have to provide it. If you try to run his stop function with no arguments, you're gonna get information that you're missing one required positional argument. It means you need something here to be passed. So we do need to pass mysec as an argument, and now Python is happy. Okay, sometimes you want to have a function that in most of the cases takes as an argument something that's always the same, but you want to be able to call it with some other value occasionally. To do it, let's try to make a simpler version of this has codon. Okay, and let's write a function that is gonna also look through a sequence, but then it's gonna look for a codon that by default is gonna be ATG. Okay, because I like start codons. So now we're gonna convert to a lowercase as before, but then we're not gonna do anything here. We've got to just check if codon is there, and then if pos is less than okay, let's do it. Let's do it this way, and then do return. Let's do it this way. Okay, and let's call it as has codon. Okay, so we've got a function that takes a sequence as an argument, and it's got to be there, and then it may take additional argument called codon. At this moment, if we don't provide it, the codon is gonna be set to default value ATG. Now, what the function does, it converts the sequence to lowercase characters, prints it out just for a moment, and then it's looking for the codon inside the sequence and stores the position in a pos. Now, instead of printing out what's the position, I just want to have a yes or no answer asking for the presence of ATG. So I'm just returning value of a expression that's checking if pos is greater or equal to 0. Okay, so now if find indeed identified ATG as present in the string, pos is gonna be set to a 0 or a positive number. So return is gonna return true as a result of the function. If pos is negative, yes, it is. It is exactly the same as in. It would work. So I just picked up find. The reason is that I might want to have a version that returns actually the position of the ATG in a string. So then I'd be able to return the position. So it's there's in many cases there's more than one way of writing a piece of code, and depending on personal taste or requirements or anticipated modification of the code, you pick up one variant of the code versus other. So in this particular case, it is exactly as in, except that in doesn't have a default value. So here, if we run it, let's try to run it. We're getting true. Is it true? Do we have ATG here? Yes, we do have ATG in the first at the 0th position, so we're fine. And we're getting what we want to. The advantage of adding a default argument is that we can modify it. So his codon called with just the sequence is gonna check for a start codon, but if we now say codon equal, let's say AGC, now we're gonna be looking for AGCs there. Okay, and now we're getting true because there's at least one AGC. There's AGC here. Or we can make, I think we can call it without giving a name. This thing also should work. Yes, because now we've got two arguments. The second one is gonna be codon, so this AGC is assigned to codon. We can do either codon equals or just keep the name, because optionally we might have more default arguments. To whatever it is, and then if we want to set non-default value to arg2, we'd have to also provide the codon explicitly. Using the name would allow us to say just arg2, and then whatever it is, and then we don't have to repeat the first default argument. So that's how to specify for a function default arguments. It's quite common. Many built-in functions do have this functionality. This includes print statement. If we do print, and let's try to print just a few characters, A, B, C, and D. Okay, and let's try to see what we're gonna get out of this thing after I get rid of a typo. So we've got the print statement with 4 arguments, and now we're getting all 4 printed, and as you notice, they are separated by a space, and then once all of them are printed, you're getting a new line printed. So if you repeat it, if you repeat the if you repeated the statement twice, oh, wrong one. Here, copy, control. If you repeat it twice, A, B, C, let's make it B, C, D, E, F, G, H. So if we use consecutive print statements and we run our script, we're gonna get 2 lines, each one corresponding to a print statement. We can modify the behavior of print by setting default arguments it can take to non-default values. One of those is a parameter called, or argument called sep. By default, it's set to a space. So this is exactly how definition of a print function looks like. We can actually see it by getting our cursor in front of print and doing Control-I, and print values. Definition is gonna tell us that there's a bunch of things that are printed. This is what goes here. There's an arbitrary number of things to be passed to be printed, and then there's a sep argument, which by default is set to space, and this is a not change argument. Nothing different is gonna happen. We can just run it once more. Output is the same, but we can put something else here. We can, let's say, put a comma, and then the print is gonna put commas in between the arguments. So now we've got a comma separated list of things. We can put sep instead of a comma. We can put a tab. Tabs are specified by saying / and t. And if we now run the code, now the second line is spaced further because there's actually a tab character placed in between EF and so forth. So the first version allows you to generate lines in a file or on a screen that corresponds to a comma separated list of entries. The second version allows you to generate lines corresponding to tab separated list of things. And those are common formats used for exchanging data, and files formatted this way can be read into Excel, for example, with minimum intervention. So this way you can process your data in some way and generate a file that can be read into a spreadsheet. Now, if you don't want to have consecutive lines separated, consecutive print output separated by a new line, you can use another optional argument called end. This one is by default and set to a new line. The way to specify new line is to say / and you start to see the pattern that / is often used to either remove or add a special meaning to a character. We had a case where we wanted to remove a special meaning from a quote sign when we were defining strings with apostrophes or double quotes. So we are using / to strip the special meaning from a double quote or single quote character. Here we're adding a special meaning to n by using \n, and this special meaning is, oh, now we want to have a new line character printed. \n is new line, \t is a tab. So now what I expect to have is, and let's go make this thing also \t. So now the first statement is gonna print out 4 characters, four arguments separated by tabs, and it's still gonna print a new line. So once we do it, let's here there's a typo. Once we print, now we've got first 4 arguments printed out with tabs. There's still a new line. Next 4 are printed out as tab separated arguments. If we don't want to have a new line but tab here, then we're gonna make one long line without tab, without new line after D, because that's what we told the print statement to do. But here we didn't. So after H there's a new line. We can convince ourselves that that's the case by printing something after it. And if we run the code now, here we've got the 3 dashes following a single line generated by first 2 statements. So here's the example of how the default arguments to functions are used. It's pretty common, and above is an example how they can be used in your functions if you find those things useful. So that's functions. We also went through conditional statements. We had already something before. As a reminder, it's something like if let's get higher. Let's steal something. Let's start from scratch. Okay, so let's start another block. So if let's say a equals 5, if a is greater, if a times a is greater than 25, print I don't know, print a, else print, or print a, I don't know, square root, print just a, something like that. So this is some stupid example of a conditional statement. We've got an if followed by an expression that we're evaluating, and then if the result is true, then we execute block that's directly following it. Otherwise, we're executing the else block. The else part is optional, so it's perfectly fine to check to do something only if condition is present and do nothing when condition is not there. So the else part is optional. If we want to do something in else block but nothing in a true branch of a conditional, we've got to say pass. So this means that we do nothing. We can't leave it empty. If there's nothing there, Python is gonna complain, because after if there's got to be something indented, we don't have anything indented, so we've got to say pass here. Okay, and then and now we should be fine. In practice, this is very rare, because in practice we would just say not and use and make it simpler. But every now and then there's a situation where we're using empty pass if else using a version like this might be more convenient. It might be, for whatever reasons, more informative to write code. It's clearer to the reader what we're doing, or it might be easier to use a construct like that rather than modifying the condition to flip from true to false. So that's how conditionals look like. And I think, and then the another variant of conditional is the one that's using elif, and we can have a chain of conditions. We can, if a is greater than 36, we can do something. Print a, let's say print b here, and then print c here. So in this case, we're first checking if a is greater than 25, then we're gonna print a. If condition is, this is pretty lousy, because if a is greater than 36, then we're gonna print the b, and otherwise we're gonna print c. If we check, let's make it a, just to make it simpler, but to demonstrate what's going on. So here we've got a set to 5. So first condition is false, so we're falling up to the second test. Second test is also false, so we're falling to else, and we're printing out c. If we've got a set to let's say 26, let's see what happens. Now we're getting a printed, so the first test was evaluated to true, so we executed the print a statement and then jumped past the conditional. If we set it to, let's say, 60 now, we're still getting a. This is because the first condition was tested, it evaluated to true, so the block following immediately if statement was executed and the rest was ignored. So the condition here, the second one in the first elif statement, was never tested. So we in this particular case might not get we might not learn that our a is greater than 36. So this is something to be aware, that if there's a series of conditions tested in a if and an if elif statement, the first one that evaluates to true triggers the block following it, and then the rest is discarded, even though the consecutive tests are also true. If we do care about it, then we'd have to use separate if statements and then check each conditions individually. Okay, so far we did go through whatever we went yesterday, and now we added a few things about functions and conversions. Okay, if you want to have a function to play with, you can try to write a function described here. Essentially, it should take a sequence like you've got here, count how many C's and how many G's you've got there, and then calculate the ratio of the sum of G's and C's to all the bases in a string. This is something which will give you GC content of a piece of DNA sequence. It's somewhat useful because GC content tells you something about properties of the piece of DNA. It's useful in different contexts. So here's a function to play with. Okay, But now, going into new stuff. First, we might want to get after individual characters in a string. So let's get myself a string with the sequence. Okay, and let's try to find one of the characters. Well, to try to get after individual characters requires us to use so-called indexing operation. The way to do it is to say my sec. So this is my variable with a string sitting there, and I want to say I want to get, let's say the third character out there. So to do it, I use the square brackets, and then I put the position of the character I'm after in the square brackets. Okay, let's see what happens when I print it. I'm seeing C. Well, that's the C I found. It is numbered as the third position because counting starts from 0. So A is position 0, T is position 1, G is position 2, and C is position 3. So this is repeating itself over and over and over in many contexts. When you've got a series of values, like series of characters inside the string, the numbering starts from 0. So that's how we get individual characters. You can persuade yourself that A is at position 0 by trying to print it out, and here we've got A. So this is how to get to position 0, 1, 2, 3, and so forth. Sometimes it's convenient to start counting from the end. So let's say we want to get the last character in a string. Well, we can say -1. When the index passed inside the brackets is negative, then Python is going to start counting from the back. So my sequence -1 is going to get us T, because this is the last character, and then if we get the second character from the end, is going to be -2, and it should be G. So this way we can print my sec it ATG. Yes, well, because you went two cells too far. Okay. Just a moment. So at this moment we're getting one character at a time. So this is formally called indexing, or we can go for more than a single character. We've got find, we already get it. So we got negative indexing, we covered find. We covered negatives here. Okay, so we went all the way here. So now we might want, I need the string, we might want to get more than one character at the time. So to do this thing is we're gonna use the construct as the one showing up in the chat, which is my sec 0:3, for example. Okay, and let's see what it returns. Well, it's gonna return 0:3. It's gonna return characters starting from character number 0. Okay, 0, 1, 2, 3, but not bigger than 3. So this is the first character that's gonna be skipped. If we want to get 4 characters, then we're gonna get 4. If we say 0:4, then we're gonna get 4 characters. This is not the length, this is the last character. This is the first character that's gonna be skipped, first position that's gonna be skipped. So we're starting from position 0, 0, 1, 2, 3. 4 is not used anymore. It is not length, because if we change from 0:4 to 1 to 4, we're getting TCG. This is because we're starting from character number 1, which is 0, which is T, and then we're going 2, 3, 4. We don't use it. So this means 4 cards. So length of what the range is gonna return is gonna be the difference between 1 and 4. So this is gonna be of length 3, as you can see. The second character is not the length. It's the position that the next position after the last that we're interested in. So this way we can go after fragments of a string. What happens if we overshoot? What happens if we use as a last character, as the second position, something that's bigger than the length? Let's make it into 40 out of curiosity. Well, we're gonna get just the string starting from 1 up to whatever is available, and then there's gonna be nothing there. But there's no error, there's no problem with overshooting, with asking for more than that's there. Another way of, so effectively 1:40 asks for characters starting from position 1 up to a lot, so up to the very end. To explicitly ask for positions starting from a given position to the very end, we can just skip the second number. This means first start with the character number 1 and go to the very end. So here's the output. This is once more the same thing as before. Here 40 was larger than the length, so we get to the very end of the string. Here we're explicitly asking for characters starting from position 1 to the very end. So we can do it in a reversed version. We can ask for positions starting from the very beginning to, let's say, 5. This means starts from the very beginning and go up to 5, but excluding 5. So we should get 4 characters there. Now 5 characters there, because counting starts from 0. So we're getting 0, 1, 2, 3, 4, 5 is skipped. And this is exactly the same as this. So that's the only difference. Now, if we want to get entire string returned, you might have guessed we're just using no numbers in front of the column and no numbers after the column, and we're gonna get entire string. Okay, so this and my sec, so those two variants are exactly the same. Now the useful part of the format here is gonna pop up when we add another column there, which then can be used to specify how many characters at the time you're supposed to jump when looking for characters in a list. Let's try it. Let's say 1, 2. Well, 1, 2, very end, or let's go 0, 2. I want one. Let's make it 0 to let's say 6, and let's jump by 3. Let's do something like this. Okay, let's see what happens. We're going from position 0, so we're going from A. We're going up to position 6, but excluding 6. So we're gonna go over 6 characters here, A, T, G, C, A, T. But now instead of returning character one by one, we're returning characters separated by 3. So we're returning the first one, it's gonna be A. But then we're going 3 positions ahead. So 1, 2, 3, and then we're getting C. So in this way, we can pick every third character in a string. If we want to get every other one, then we would say 0, 6, 2, and we would get every other character within 0 to 6 range. So we would get A, G, A. Let's see if that's the case. Yes, that's the case. If we want to get every other character from entire sequence, entire string, then we can leave both positions empty, and then we will get A, G, A, G, A, and A, and so forth. So here's every other character that we're interested in. Now, all 3 positions can be either positive or negative. Positive means we're counting starting from the very beginning. Negatives, we're counting backwards. For the index, it means we're going from the end towards the beginning. So if we do something like this, our range means start from the very beginning. I mean, look for the look starting from the beginning of the string all the way to the end, but go from the very end by 1 character. So if we run this thing, we actually reversed the string. Instead of reading it ATGCA, we're reading it now TGACCCC. So we just in one line reverse the entire string to go backwards. So it's another way of a convenient way of going after characters in a string. So those are variants of ranges. The variants with negative numbers are sort of tricky when starting. The way to get an idea how those things work is to play and plug in different numbers, use a test string and play with it until you're getting the feeling how this thing is behaving. Things to remember is that for the beginning and for the start and end of the range, the first number, the start, corresponds to position where we're supposed to start going through, and the second, the end position, is position next to the one that we're looking for. So going from 1 to 4, it means go through position 1, 2, and 3, and 4 is the first one skipped. That's how it's defined in a pretty consistent way. So that's how we're going after individual characters in the strings here. So we've got steps now. it still gets us the result as a one string. We're still not going one character at a time when we ask for MySec 1 to 4. The result is just another string. In many cases, we want to go after individual characters one at a time and then do something with each character. We want to perform the same operation on each character. To do this thing, we've got to start writing so-called loops. Those are the statements that allow you to specify how to run a code in a repeated way. So let's try a very simple one. The simplest version is starting with the 4, and then we've got to have a variable that is gonna be set to the value that we're gonna generate in our series. So let's say for C in let's get our MySec here. Okay, so here's our sequence. We want to go one character at a time. So let's try to look for C in MySec. Okay, and now we've got a block of code that will be repeated as many times as there are characters in MySec, and every time the code will be run, the C variable will be set to consecutive characters. So let's try to do something very simple. Just let's print what's in the C. Let's do print C. Okay. So now let's run it. And here we've got our sequence printed one character at a time. The first time we went through the block, the C was set to the first character, and the first character was printed with a new line. Then we got the second character, third, and so forth. So whatever is run in a block here is gonna be run as many times as many characters is there every time the C is gonna be set to consecutive character. If we don't want the new line, we know how to get rid of it. We can say end equals to nothing, and we're gonna run it, and here is the string printed out once more, but now we're printing one character at a time. We can persuade ourselves that that's what's going on by I'm gonna comment this thing out. We can put something else than empty string as a separator. I can put a space, and now I can add spaces in between the characters, or I can place semicolons in between, or whatever is convenient. So here's one of the ways to go after the characters in a string. The default order is gonna be just the order is gonna be the order of characters. So we're going A, T, G, C, A, and so forth. If you want to scan the string from the end, the simple way is to just go over not our string, but over the string reversed. You've seen just a moment before how to reverse the string. We can just go over entire string, but in a -1 direction. And now if we run here, here's our string that's reversed. So that's another way of generating inverted string. We don't have to, obviously we can do whatever you wish inside the body of the loop. We can, for example, build our inverted string by hand, sort of. We can my invert, but we've got to start with an empty string here. Okay, and now I'm gonna print my C in a loop, but I'm also gonna do my inv equals my inv plus C. Okay, and then once I'm done, I can do print my inv, and I'm gonna put something to mark it here. Okay, so let's run this thing and then see what's happening. Okay, so what did I do? Okay, so I'm started with the sequence given here. Okay, and then I went through this string going from the end, and every time I got a new character, I appended it to my inv variable. Okay, and once I'm done with the loop, I just printed it out with the two columns in front of it. It fell in the same line as whatever I've got here. This is because the last print statement in the loop didn't have anything to mark the new line. So I can fix it by first printing nothing, and then this will generate me a new line on its own. So now I moved everything one line down. So this is printed on a separate line. Now, before using my inv in a loop, I did have to initialize it. I set it to nothing here. The reason is if I skip it, it's still working. Why is it still working? Well, because, okay, the reason is I've got to clean it here, remove everything. Okay, and now clear. Okay, so now I don't have any values, any variables defined. I will try to run this piece of code, and now I'm getting the name error. You've seen this thing before. This is because my inv was not defined when I was trying to concatenate the first character to undefined variable. So so that's why I've got the error here, and that's why I need the statement here. Once it's defined here, once it's defined, now it's gonna behave as it should. So here's another very simple example of a loop that goes over individual characters in a string. So here's how to go after one character at a time and do something with it. In our case, we just either printed it or appended it to build a string from individual characters. So here's a more practical problem. Let's say we want to get something called reverse complement of a sequence. For those of you who are not biologists, here's a very short description of what reverse complement is. In principle, DNA is built out of two chains. Each chain is built of monomers of units that are conventionally named ATGC, okay, and those two chains are anti-parallel, so one goes from the left to the right, the other one goes from the right to the left, and those two chains are twisted like a helix, and they are held together by interactions either between G and C or between A and T. So if we know the sequence of one of those chains, we can infer what's the sequence of the other by going in a inverse direction, going backwards along the original sequence. This will take care of the anti-parallel direction of those two chains. And then we've got to switch from G to C, and from C to G, and from A to T, and from T to A, to make sure that the pairing is right. So let's try to get this inverse complement sequence out if we've got the sequence. No, let's start our reverse complement function. Okay, and first we've got to make space for the sequence we're gonna build out of. I'm gonna be lazy, so I'm gonna make this thing shorter. Okay, and I'm gonna rcom, let's say. Okay, and the very end we will want to return. We will want to return our rcom. Okay, so here's a skeleton of our function. We can try to run it. So let's get ourselves a piece of sequence here, and let's put it here. Okay, and now let's call the function with my sequence here. Okay, so here's a starting point. I just prepared myself a test sequence so that I can see if the function is working fine. I made myself a skeleton of the function, which at this moment is doing nothing. It's just returning the empty string that we will fill with the reverse complement. And once we've got the definition, I'm running the function and see what happens. So let's run it. Well, we've got as an output empty string, so we're fine. Okay, so now what we've got to do? Well, we've got to take our sequence. Okay, I somehow prefer to always work with defined case, so either lowercase or uppercase. So I'm gonna do the same thing as before. I'm gonna make sequence into sequence lower. Okay, this way I make sure that I always do have lowercase characters. Some annoying person might type something like this, and I'd be able to deal with the sequences provided like this. So that's why I'm always switching to either lowercase or uppercase. It doesn't matter which one, but I am trying to be consistent and use one all the time and make sure that the input is converted into a standard version. Okay, so now we've got to go over our sequence, but we've got to go in reversed order. So here's the place for our loop. We're gonna do for character in sec -1. Okay, so this is gonna generate a series of C's starting from the end of a sequence. So let's for a moment plug it into rcom, concatenate it to rcom. So let's do rcom is equal to rcom plus C. Okay, and let's see what happens. I'm expecting I'm gonna see my input sequence in lowercase and written backwards. So let's see if my guess is correct. Well, I'm getting TGACCG, TGACCC. So that's my reverse sequence. It changed direction. There's more than one way to generate it. Okay. Here I'm inverting the initial sequence, and then I'm appending individual characters to the end of the ARCOM. An equivalent version is to go through the sequence without reverting it, but concatenating C with ARCOM. C with ARCOM. And my guess is the result is gonna be the same. Yes, it is, because now I'm generating a series of characters starting from the very beginning, but each character is added in front of whatever I've already got. So in this way, I'm reversing the sequence, but built-in function object is not which. So then you've got the wrong function, the wrong data type. If object is not scriptable, it means that it's not a string essentially. So that's the problem. So if I had ARCOM set to 1, if I had sequence, if I had, let's cheat for a moment, let's make sequence set to something like this, So you're gonna get no, you're getting slightly different error, but it's same meaning essentially. It means that sequence is single value. If you try to have sec1, this is gonna generate the error you've got. No, sec1. Sec1. Let's see. No, it's still. I don't know. I'd have to send me by email this snippet of the code with the error. I'll try to look at it after the class. So, but here it's most likely problem with the data type. Okay, so once more, I'm converting sequence to lower. Now I'm going over sequence, and then I'm reversing direction by concatenating in a funny way. Let's. Yeah, it could be if there's no quotes. Yeah, but maybe I don't know. I'd have to see the code. So, but we went originally here -1, and here we're concatenating like this. So let's see once more if we work. Yeah, we're flipped. Now this can be simplified. We can instead of concatenating using the full version of the long version of assignment, we can say ARCOM plus equals C. This is, I mentioned this thing early on. So this means take ARCOM, concatenate C to it, and then store in ARCOM. Let's see. It means that we're setting the value of ARCOM to nothing. Without this statement, if this thing is missing, we would have an assignment here well, let's go back here. We would have an assignment here that relies on the value in arcom. During the first pass with the statement commented out here, there would be no value there. It wouldn't be, there would be some random thing. Python doesn't let you use a uninitialized variable. So this thing will generate an error. It would tell you that you've got arcom referenced before assignment. It means that this arcom wasn't set before you're trying to concatenate something to it. We are setting it here to empty string, either single quotes or double quotes would work. This just sets the arcom to empty string. So here it works, here it doesn't. So the reason is in assignment here, the arcom had no value during the first pass, so we crashed. So we need it here. Okay, here concatenation is done in an explicit way, and then the result is stored. I think the alternative is to use the plus equal thing, and we're getting exactly the same. Those two variants are equivalent. This is just the shortcut. It's less typing, but sometimes using those enhanced assignments is less clear to read. So you might want to use the longer version, even though it can be shortened, but the code might be more readable. So some decisions are made based on how readable the code is. And as you see, there's at least 2 or 3 different ways of doing whatever I'm doing now. Okay, but going back to reverse complement. So we really do not want to add the character here. We want to add the complementary variant of C. So to this thing, we've got to check what the C is and then put the corresponding character there. So let's do the test. Let's do if C is A. Okay, we've got to put into arcom, we're supposed to put T, because T and A pairs with each other. Now we've got more options, so we're gonna do elif C is T. We've got to put there A. Okay, now we've got 2 more things to go. If C is set to C, we want G. Okay, and here's the fourth option is we're gonna get the G, so we can either do another test or we can just follow off with else, and then we're gonna put in C. So the last case corresponds to C being equal to G. We checked for A, we checked for T, we checked for C. So the last possibility is G. So then G should be converted to C. Okay. So let's see what happens. Does it work? No, because I've got a typo. It tells me where there's a typo. So here there's something missing here. Yeah, I'm missing a single quote to end the A character here. So let's see if it's gonna work now. Yeah, so we've got ACTGG here. So that's what we've got here. So we should get going from the back. We should get A, we should get C, we should get T, we should get G. So it looks like we've got our reverse complement done as it should be. This is one of the ways of doing it. There's more variants of that. We're -1 defines in C. Oh, so what this thing means is go over our string starting from the very beginning. This is because the first position is empty. Go to the very end because the second position is empty, and go by one character because it's one, but going from the end. So this effectively reverses the order of characters that I'm going through without the slice, without the range provided here. I would go A, T, G, C, A, and so I would go from the very beginning to the very end. I want to go backwards, so I'm saying I want to go from the very beginning to the very end, but in a reverse direction, going by one character. So that's how it goes, and that's why my sequence is going in the reverse direction. If I don't want to reverse the direction, I can skip it, and now I'm gonna have the sequence put together in a reverse, in opposite, in the wrong direction. So I'd better use the -1 here. So is yes. So this is exactly the same as sec. So there's no point of using this thing. You can just say sec, but if you want to reverse direction, you go -1. So here's our reverse component. Okay, so we had some fun with the strings. As you notice string is actually not a single value. It's not like integer where there's just one number there. String is actually a series of values at 0th position, 1st position, 2nd, and so forth. So this is actually a list of characters that are interpreted as a piece of string. A more generic data type that allows you to have different things put together as a list is something which is called a list. Okay, so let's try to use some lists. So let's try to make ourselves a very simple list, my LST. And to build a list, we can use square brackets, and then we're gonna have individual values listed there. So let's make a list of numbers. Let's make a list starting with 1 in the 1st position, and then 6 in the 2nd position, and 8 in the 3rd position, and 9. So here we've built a list with 4 elements. The 0th one is 1, this first one is 6, the 3rd one is 8, and the last one is 9. We can print it, my LST, and we're gonna get the default format where this form of list is reproduced. We can put different things there. We can put strings there. We can put a bunch of strings in the list. Okay, like this. And when we print it, now we're gonna get a printout of a list composed of now of four characters. We know it's 4 characters or 4 strings. We know those are strings because now each element is wrapped in a single quote. This is the default way the print works with lists, and that's how it shows the elements in there. We can mix types of the elements, so we can make it like this. Okay, it's perfectly fine as far as syntax go. Lists can be composed of elements that are of different types. You can notice it when things are printed out, that the first 0th element is a string, second one is integer, third one is string, fourth one is integer. It's not advisable, but because then it's really easy to confuse yourself and run into problems, because some pieces of data might be processed as strings, some as numbers, and it might be hard to track what's the problem. So it's better to use the same types, but there's no formal restriction on making the types of elements the same. Here we've printed out a list as a one piece of data, as one variable. If we want to go after individual elements, we use the same approach as with strings. We can use square brackets, and we can ask for element number 1, and we should get 6. Here it is. We can slice, so we can ask for element 1 up to 2, 3, let's say. And now we're gonna get element number 0, 1, 2, and 3 is skipped. So this is exactly same way as with strings. It's the same thing. The only difference between string and a list is that string is composed of elements that must be single characters, and in case of strings, you can't modify it. Strings are so-called immutable. You can't modify a string, but you can modify element in a list, just to demonstrate this thing. So let's say we print our list like here, then we can modify one of the elements. Let's say my lst at position 1, I want to make it, let's say, -6, and then let's print it once more. So now when we run it, here's our initial list. This is the list built here. Here it's printed. Now we assigned -6 to the first, into the element with the index 1, and then we printed it once more. Element number 1 is 6, so now this 6 became -6, and that's what happened here. With strings, it doesn't work. My str, let's make a string 1, 2, 3, 4. Okay. My str, and let's say you feel like my str at 1 is supposed to be, let's say, 4. Okay, let's try to run it, and we're getting not none. No, let's run it, and we're gonna get error. String object does not support item assignment. Well, that's because strings are unmutable. You cannot modify individual character in a string to make a modified version of a string, you've got to actually build a new string, a copy of the string from a scratch, and modify characters on the fly, or copy them without modification. So that's the difference between lists and strings. Otherwise, those two things are very similar. So you can make a string into a list if you feel like it. To do it is you just coerce, you just cast a string into a list. So let's try it. My my S list SLST is list, and let's feed it with my string. Okay, wrong thing. Copy. Okay, and now print my SLST, and let's see what happens. Now I've got still a bad thing here. No, because you're gonna replace is gonna return you a new copy of the string with the replacement. It's gonna be the original string will not be modified. So there are functions, or there are methods that will perform operation on a string, but whatever they return is a completely new string. They don't modify the string provided as an argument, or a string that was that the method was run on. So that's why sometimes you've got to go through individual characters one at a time, and then build strings from a scratch. So here we made so one way to do it is to first convert a string into a list. Okay, and here we've got originally, let's try my str, my list. So here I'm printing my initial what happened, my str, that's my str. Okay, so here's my string. Okay, I'm printing my string, then I'm converting my X and V, and let's make myself a nicer cell. Okay, so let's so I'm starting with a string, I'm converting the string into a list, and then I'm printing the string and then resulting list. Let's see what happens. So here's my initial string, and here's the string converted into a list. So here I once I've got my list, now I can set 1 to something, the element at the index 1 to something else. Let's say -2. Okay, and then I can print it once more. So here's my initial string after conversion into a list, initial string once more, the list after modifying second element to -2. As you notice, even though there are numbers here as characters in a string, the generated list is gonna be composed of characters. So those are not numbers. So conversion is pretty dumb. It's just splitting string into individual characters without looking at the meaning. My string. Well, the question is, does str my list convert to a string? Well, we can always try. That's right. We can now print str my slst and see what happens. Okay. Well, it sort of converted it, but this is exactly what you see when the print is taking a list. The conversion of a list to a string, like here, is generating whatever you see here. So it's not gonna get you the string you started with. So to make to merge individual elements into a single string, single string, you've got to use a different construct. I think it would look like this: join. I think, yeah. So that's how it will look like. It looks kind of scary, but the way to interpret this thing is we're starting with an empty string, okay, that's gonna be used as a separator, and then use this separator to join elements of my list, and that's what happened here. We had the list made out of character 1, then two characters -2, 3, 4, and we joined all of them into a string using as a separator empty string. If we want to put something else there, we can put, let's say, a colon, and now we'll have individual elements separated by colons and presented as a string. When you run it here, what's here. So this is another way of printing out lines that are either space separated or colon separated or tab separated. Here's a this this should work. No, this doesn't work with tab somehow. I don't know. Well, it works with colons. I'll find out for tomorrow why I can't join on a tab, but it should in principle. So anyway, this is the way to join the list into a string. The conversion with str doesn't work. Okay, so so far we went through building strings explicitly by listing elements in a square brackets. We went through conversion of a string into a list. Okay. We went into indexing. We went through changing individual elements. Okay. Now, what else we can do with lists? Well, a lot, because now with lists we are free to modify them. Okay, with strings we can't. With strings we're always either looking at something in a string or generating a new string from the initial one, with initial one not being modified. With lists there's more freedom. We can have once more. I need a list. Let's get myself it's easier. My L. Let's make it, let's say A, B, C, okay, D, okay. So let's try. So if we print my L, I'm gonna just yeah, I'm getting too many characters. I'm gonna get 4 elements here. So let's try to append something to the list. Let's try to add another element. Okay, the way to do it is to start with our variable, with our list, then use a method called append, and then we'll append character E to it. And now we're gonna print my L once more. Okay, so initially I should see the same list as before, and then after appending, I'm getting another character added. As you see, in both print statements, I'm referring to exactly the same variable. Join print T. Oh, I see. Okay. Oh, I see. Yeah. Okay, so that T print. Let's see. Yes, it does, but is it? Let's see the type. And let's see what it is. Yeah, so I think it might work. So then I'm puzzled why this thing doesn't this thing. It could be that peculiarity of the spider and the way it's spitting out strings with tabs. I'll try to play with this thing and report tomorrow. Okay, so anyway, here you see that both print statements are referring to the same variable, but we didn't assign anything new there to it. We're using it all the time. The only thing we did is we run an append method to add another element, and we're getting a longer list. So we modified our initial list. So we can modify lists by adding stuff out there. We already modified lists by modifying individual elements there. So we indexed it. Another useful thing is to reorder list based on the values that are stored at individual locations. So let's change this thing F, make it Z, and make it X, something like that. So let's get ourselves a list with bunch of characters there. If we want to sort the elements of the list, we can just say my L, I think sort. Okay, this is if we print it. If we print it, we're not gonna see anything. This is because the sort method is one of those that do not return a value. This is the same thing with print. If you're curious, we can try to do print print the value returned by a print statement of some sort. Okay. And let's see what we get. We're getting AA printed because print AA results in getting AA printed. But then the outer print is trying to print the value returned by the function call, and we see none. This is because print method doesn't return anything. The same thing with the sort method. It doesn't return the value. So when we try to print the result, we're getting none. Did it do anything? Well, if we print our myl, print our myl, now the list is sorted. We started with AFZX. Here we've got AFXZ. So the list was sorted and was sorted in place. So the method doesn't return anything. It just modifies whatever is in our variable. The reason for that is that the lists can be very, very large. They can fill up a lot of memory. If sorting were to return a copy of a list, it would require one more as much memory as the list was originally using. So this is not efficient in terms of memory use. So the sort method is doing sorting in place, and then it's easier on your hardware. Essentially, you don't need that much memory if you're dealing with large chunks of data. There's an option though to sort and generate a copy of a sorted list. This might be useful if you want to have both the original unsorted list and equivalent sorted. To do sorting, no, I'm just doing this. I'm just printing this to show you that sort doesn't return anything. Although you might hope, because in many cases I called methods and then printed the result. So sort is strange in a way that it doesn't print out anything, doesn't return anything. And there's a reason for that, the efficient memory usage. But in some cases we do want to get both sorted and unsorted version of a list. That's right. Once this is run, we've got no way to go back to original order, and we might want to keep track of it. So if we want to have another copy of a list, but it's sorted, then we can just use a sort function. We can do sort myl, and now what? No, it should be list. It should be sort. Oh no, sort. It should work. Sort method. Sorted. Sort, and there's a function called sorted that takes a list as an argument, and once you run it, now it's gonna return the sorted version of the list. So now we can have a my sorted list. Okay, and now once we run it, we can now let's print my L and my SL. Okay, and I'm not gonna do this thing. So here I've got my original list. I create a copy of this list by sorting the original one, and now I'm printing the original one and the sorted one. Let's see what happens. So here's my original list, and here's my sorted list. Yeah, so the thing here is just to show you that sort returns nothing. That's the only point I wanted to make. So normally you would run this and then print the sorted version. So this would be the normal usage. I'm doing stupid things just to show you what are how things behave. So here's sorting of the lists. Now the sorting is performed according to the order of the elements. So for characters, it's gonna be alphabetical order. For numbers, it will be numerical order. But if numbers are but if a list is composed of a series of strings that are numbers on their own, like here, if we this is gonna go, if we sort the list of strings that happen to be looking like numbers, the sorting is gonna be funny, because that's how numbers are sorted. The strings with numbers are sorted. The first is gonna be 1, then the next one is gonna be 1 1, because it's following 1, but it's in front of 2, and then so this is not numerical order. To have numerical order, you'd have to have all the elements being numbers, and now the ordering is gonna be according to order of numbers. If you use mixed elements of mixed types, it's not gonna work. If we try to sort something like this, we're getting type error. This is because it's not clear what's the relationship between a character 3 or string with many characters and numbers. There's no rule for ordering strings and numbers together. So this is another reason not using mixed, not using a list with mixed elements. So, but as long as elements are of same type, sorting will most likely work, but not always the way you think. If you're trying to sort strings with numbers, then you're gonna get alphabetical order, not numerical order. So that's sorting. Okay, we can also remove a given element. So let's get ourselves a string of some sort. If we've got my L, we can do my L, and we can remove, and remove is gonna remove element that we specify, as far as I remember. So let's see what happens. Let's print my L. Okay, and let's see what happens. Yeah, if we're gonna call a remove method on a list, we've got to provide an element that's gonna be removed, and then the element is gonna be gone, as you can see here. We asked for removal of A, and the first element is gone. If there's more than one occurrence of a given element, let's see what happens. Well, the second element stays. So removes only the first occurrence of a matching element. If you want to remove all the A's it's not gonna work. So that's how to remove element when we know what it is. And then if we print the result of the remove method call, where is it? Here. We're getting nothing. Remove is another of those methods that don't return a value. In just modifying the string that's used for the method call, and then we've got to go to the go after the modified string. Now, remove is removing element by value. If we want to remove element at a given position, then we've got to use a pop method. Let's try it. Once more, we're gonna have a myl, okay, and we're gonna do myl pop, and let's remove element number 1, or with the index 1, and then print myl. This is presumably gonna remove f, at least that's what I hope. Let's see if it's the case. Yes, f is gone. And does it return anything? Print. Let's see what happens. Now pop is gonna return you whatever was removed. So here I went after the element with the index 1, so after f. The list is shorter and f is missing, but it was returned by the method call. This is needed because we don't know what the value is. So there's a chance to retrieve the value that was removed from the list. For remove, we know we're removing a, so there's no need to return the value because we've got it, and the list is not returned because we can if needed we can get to it by the name of the variable. So those are two ways of removing things from a list. None of them is available for strings because strings, once more, can't be modified. You can perform equivalent operations on a string, but to do it you have to iterate over characters and then build the resulting string from a scratch. So strings can't be modified, lists can. And here are examples how to remove things from a list. We had examples before of adding things to a list. Okay, and for list we can get a length as with string. This is function that works both with list and strings. We can say len. Len myl, and we're getting 5 because we've got 1, 2, 3, 4, 5 elements in the list. So that's that. Those are the basics of lists and how they differ from strings. Now, so far we went through the string elements one at a time using a very simple loop that was doing something like this: for C in, let's say, A, B, C, D, print C. So this was our our simple loop that we used for building reverse complements. So let's run it once more. Right here, here's the simple case. It will work with a list. We can, instead of using a string, we can just use a list to iterate over. Okay, and then if we run it, we're getting one element of a list at the time. So we're getting A, F, Z, X, A. Okay. And we can do the same things, same tricks, play the same tricks as with strings. We can reverse the order. For example. Okay, that's a better way to. Here's or go without reversal, or go every other element. So this is working both with strings and lists, but there are alternatives. We can, instead of using the construct, we're going over a given list one position at a time. We can actually use the indexes to retrieve individual elements. To do this thing, we're using a different version of a loop. It looks like this. It still does for something, for, let's say, for I in, but now we want to generate a series of numbers that we will use to retrieve the values from a list, or for the matter from a string. To generate the range of values, we use a function which returns one. We just range starting from 0 to, let's say, 10. Let's do this thing, and let's print I. Okay, so this thing is gonna return us a range of numbers. And I don't want to print this thing anymore. Okay, so here's the list of numbers printed one at a time. Okay, so in principle, it's very similar to whatever we're doing here, except here we're getting one element at a time from a list or from a string. Here we're getting one element at the time from a range of numbers, from a series of numbers returned by the range. If you actually print range 0 to 10, let's see, is it gonna print no? So no, okay. So this thing is gonna generate us a list of numbers. So now we can use those numbers as indices to get elements in a list. Okay, so we can use I as an index in my L. Okay, like this. Okay, and if we run it now, we're gonna get 1, 2, 3, 4, 5 elements here, but then we hit index which doesn't exist, and this generates an error. So we've got to be careful to generate the range that goes up to the last index. Well, we can get the last index by getting the len of our myl. Okay, and now our range will start from 0. We'll go to the length of the string, and now it works, and we're getting our elements from the list. This sort of suggests why ranges either specified here or the ranges when specified in using this variant when slicing, why the upper bound corresponds to one more than the element we want to get to. It's because if it was exactly the one that we need, we'd have to put here plus 1. We providing here as the end of the range the number that it's the next one to next to the one that we need is making statements using the length function easier. So this thing is gonna get us what we want without counting one or adding one or subtracting one from whatever len is returning. So here we get and this is a syntax error. So here we're iterating over a list using a range of numbers. In principle, we can also in principle, I want to comment this thing. In principle, we can also, I think, specify a list here. Let's say 1, 2, 3, and iterate over a list. So whatever follows in has to look like a list. So in a version here, my L variable is a list, so it's fine. Here, the range function returns something that looks like a list, so we can iterate over it. Here, instead of providing a variable, we just hardwired a list with individual numbers here. So this for I in something construct is quite universal. The only constraint is whatever follows in has to look like a list, or in jargon it's called iterable, and then we can go over things that are there one element at the time. So this is a way to go after elements in a list or in a string by using explicitly indices. It depending on circumstances, sometimes you just use the simple form. Sometimes you want to access only specific indices, so you might come up with a variant where you're using indices, and then you're checking while iterating if the indices are the ones that you want to work with. So, for example, what you can do is you can have a case like here. So in range to my. So, for example, you might want to set the condition that if I is divisible by 5, then or by 3. You want to print something. The point is that you want to iterate over entire entire list, but then only for certain indices you want to do something with them. Here I'm getting I'm printing every third index, every third element. So this can be achieved by getting by using the range, but in general the condition here can be more fancy. Let's say if I want to have things that the more complicated condition on I, so then I've got the freedom to specify here something in more complicated way. So that's the reason to go in certain cases by indices. So that's another version of a loop, and then I think we're gonna stop here because we're running out of time. So we're gonna stop here, and you might try to practice by modifying the reverse complement thing that I wrote somewhere here, instead of iterating in a simple way. You might just modify it a little bit to use the alternative version of a where did I go? By using the alternate version of the loop, and you might actually try to actually convert the string into a list first, then iterate over the list, and then generate reverse complement as a list. So I mean there's so the idea would be to have a reversed complement index where you would have a for I in range. Well, so you would make a else equals to list sequence like this. So you would do this, and then you would go over the range, and then you would return a list, not the sequence. In some applications, it might be useful to convert the string, to convert the sequence provided as a string into a list with individual positions provided as elements of a list. So this might be alternative version of a reversed complement. So we're gonna stop here. Tomorrow we'll finish up with and the last data type worth mentioning, which are dictionaries, which will be sort of similar to lists, but with a few quirks, and then we'll finish up with trying to switch from running snippets of code as cells in a Python into to running a program in a single file. This is how normally Python programs are run, from a command line where you've got a file with your program sitting there. You pass some arguments to the program, pass some data to the program, and then run it outside of a spider. So that's what's gonna happen tomorrow. Okay, any questions? No questions. The according to Eloy, we do have recording from the yesterday on UCLA box. We'll have the recording of this session also there as soon as he puts it there. I'm gonna stop recording now. Where is it? Stop recording now. Do you want?